Hello, this is Mr. Stansbury. I'm going to take you through the 10H assignment. All right, so let's start with number 1 here. Find the value of x. So we have a couple angles and one side, and we're trying to find the other side. So this is the law of sine. So if you have an angle and the side across from it, then you should be able to find other pieces as long as you have one other side or one other angle. So if you look here is our angle and side across from it. Okay, so that means we can figure out, since we have this angle, we can figure out what that side is. So we're in really good shape here. So let's try this one out. So we'll do sine of A, so sine of 37 over the side A, which is 23, should equal the sine of 48 over the x is what we're looking for. Okay, so we can just do cross products, right? So we'll do excuse me, 23 times sine of 48, and then we'll end up dividing by the sine of 37 there at the end. Okay, so let's do, it's usually best to do 23 times sine 48 instead of sine 48 times 23, because it's just going to give you better chances of getting the right answer here. So we got 23 sine 48 gives us 17.09, and then we're going to divide that by sine 37. So sine 37, and we get 28.4 centimeters. Okay, and that's all there is to that. Okay, so B here, we've got an angle and the side across from it. So we got these two are going to help us out here. So we'll do sine of the angle 48 over the side across from it, which is 11, is going to equal sine of 115 over the x, which is the side across from it, right? So again, cross multiply and divide, and that'll tell us what our x is. Okay, so let's see, we got 11 sine 115 equals 9.96. Divide that by sine of 48, and we get 13.415. So let's go with x equals 13 point, what was it, 4? Yeah, 13 point, excuse me, 13.4 centimeters for the x. Okay, all right, and then for C, we've got the angle and side across from it. So we'll do sine of 80 degrees over 4.8 equals sine of 51 over x. Cross multiply and divide. Okay, so we got 48 sine 51. Oh, sorry, not 48, but 4.8. Okay, so 4.8 sine 51 equals 3.73, and we're going to divide that by sine of 80. And that gives us 3.78. So let's go with, let's see, they already have it to the nearest tenth here, so I'm going to go to the hundredth, 3.79. 79 kilometers. Okay, or 3.8 would be fine too. All right, okay, let's move on to the next one. Number 2, in triangle ABC, find side A if they give you all this stuff here. So I would definitely suggest drawing the triangle here. And it doesn't really matter if it's to scale, so I'm just going to draw myself a little triangle here. And I'm just going to call it A, B, and C. So angle A is 63. We're looking for side A, which is this one over here. Angle B is 49. Right? And then side B is 18. So it says find side A. So look, we have angle and side across from it, and then that angle will go with that side there. So we'll do sine of 49 over 18. So there's 49 and the side across from it. And then equals sine 63 over x. Cross multiply and divide. Okay. So let's do that. We'll do 18 sine 63 equals 16.038, and then we're going to divide that by sine of 49. So that gives us 21.25. So I'm going to go with 21.3 if we round it. 21.3, and these are in centimeters. Okay. For B, again, just draw any old triangle. Doesn't have to be to scale, as long as you can understand where all the pieces are. Let's see, we got angle A is 82. So this would make this side A. Let's see, side C, we'll just put that here, is 25. So that would make this little c, and that makes this big B, and that makes this little b, right? So let's see, side C is 34. And then we are looking for side B. So this is the x that we're looking for here. So we have this angle and the side across from it. We're looking for this side here, so we need this angle right here, but they didn't give it to us. So what we have to do is we have to find it. But since we have the other two angles, that should be pretty easy, right? It should be 180 minus the 25 and minus the 82, right? That should give us angle B should equal that. Okay, so let's figure that out. So we'll do 180 minus 25 and minus 82 gives us that angle B is 73 degrees. So we'll put 73 in here, and now we have the information that we need, because we have this angle on the side across from it, and we have this angle, and that's the side we're looking for. So let's do sine of 25 over 34 equals sine of 73 over x. Cross multiply and divide. All right, so we'll do 34 sine, let's see, sorry, 73 equals 32.5, and we're going to divide that by sine of 25, and that gives us 76.93. So x equals 76.9 centimeters. Okay, so that one's a pretty big number compared to the other ones, but also if you look here, the 25 is a really small angle and 34 is across from that, so 73 is almost 3 times as big as that. So that looks like that's a pretty 77 looks like a pretty good number for that one over there. Let's do C then. Draw ourselves a triangle. Let's just do A, B, and C. We don't even have to worry about it afterwards. So little a, little b, little c. Okay, so find little c. So that's this one, x. If b is 21 degrees, c is 48 degrees, and side A is 6.4. So this is 6.4. So this is the one side that we have, so we need to know what that angle is over there. And again, they didn't give it to us, so we got to figure it out. 180 minus the 21 and the 48. Okay. So 180 minus 21 minus 48 gives us 111. So this here is 111 degrees. Okay, so then now we can say sine of 111 over 6.4 is going to equal sine of c, because this is the other side that we're looking for, side C, so we need angle C, so we'd do sine 48 over x. Cross multiply and divide. Right, so 6.4 sine 48 is 4.75. Divide that by sine 111, and we get 5.09. So we'll call x equals 5.1 centimeters, we'll call it. Okay? This one here, since we're already at we have all of our other numbers to the 10th, it might be wise to make this 5.09 centimeters. They didn't specify, so I wouldn't really worry about it, but it's probably a little bit better that way. And then that's 3 significant figures as well. Okay, let's look at the last example, last problem, which is number 9. Find all unknown sides and angles of PQR if, and then they're going to give us all these sides here. So we've got a lot of room. I'm going to make a big triangle, P, Q, and R. We know that angle P is 42 degrees. Side PQ, so P to Q, which is the same thing as side R, PQ is 21 centimeters, and then side QR, which is side P, is 17.3 centimeters. Okay, so we got to find everything else. So let's do this. We can use the law of sines because we have the angle and the side across from it, and then we can find this angle here because we have the side across from that. So let's do sine of 42 over 17.3 equals sine theta, or R, whatever you want to call it, over 21. So again, we'll still do cross products, right? So bringing out our calculator here, we have 21 sine 42 gives us 14.05. We're going to divide that by 17.3, and that gives us 0.8122. 0.8122 equals sine theta. I'm going to do this. I'm going to do sine of R. Okay, so now that we're looking for an angle, all we do is do second sine, and instead of putting 0.8122 in there, let's do the answer because this will give us a more accurate answer. So we'll do second sine, and then we'll do second answer, and that gives us 54.3 degrees. So R equals 54.3 degrees there. Okay, so this is, put the new stuff in red, 54.3 degrees here. Okay, so now we have these two angles. We can find angle Q by doing the 180 minus the other two angles, right? So 180 minus 42 minus 54.3 will tell us what that other angle is. Okay, so let's do that. 180 minus 42 minus 54.3 gives us 83.7 degrees here. So this is now 83.7 degrees. And then now we have enough to figure out what this side over here is. Call that X for now since we don't have it. Right? So we can do, I would highly suggest using the angle and the side that you were given instead of using the 54.3 and the 21. Use the 42 and 17.3 because those are both, neither of those have been rounded off. That's been rounded off. So sine 42 over the side across from it, which is 17.3, should equal sine of 83.7 over X. All right, cross multiply and divide, and away we go. So let's do 17.3 sine of 83.7 equals 17.19. Divide that by sine of 42, and that gives us at the other side over there is 25.69, so we'll call that 25.7. 25.7 centimeters for that other side over there. All right, so 25.7 centimeters. Okay, so that's all we have for this here. I'm going to just show you something really quick on this one here, because this is one of these triangles. It's called the ambiguous case. It could be two different possible triangles here. So this is one way that we drew our triangle with this 42 and this 21 and this 17.3 here. Another way that that triangle could look like, since this side is shorter than that side, and again, don't worry too much about this, but I just want you to at least be aware of it. Here's P, right? And then here's our 42-degree angle, we'll call it. And then here's the 21 centimeters. And then now this side here, we drew a 17.3 this way, but it could actually go in closer like this at 17.3 degrees here. And then you'd end up having a different set of answers here. Okay, so really probably a better way to have originally drawn this so that you can figure this out is, let's put P down here, the fixed angle we put over here at 42, and we know that this side here is 17.3. Oh, oops, I messed that one up. Hold on, let me get this right. Oops. Okay, this is our 42 degrees. We don't know what this side length is here, but we do know that this over here, if this is going to be, say, R, we know that this side over here is 21, and then this side across from P is 17.3. Okay, so we just know these two sides in that angle. So we don't know what this angle or this angle or this side is. So this here, kind of like how we drew it over there, just rotated, works just fine. But this, since this side here is shorter than that, the way you can look at this is this side here could actually kind of, if you unhinged it from this right here and just left it swinging right there, you could actually swing it over like this here, and then this, oops, this here is still 17.3 to 3 centimeters. Okay, so then now you would have this little skinny triangle instead of this bigger thick triangle. So it could be either one of those triangles. That's called the ambiguous case, because you don't know which one it is. So normally you would solve this for both of them. We're just going to worry about just the one for now, but I at least wanted to mention that so that you knew that that was there. All right, so if you have any other questions on any of this stuff, please feel free to ask in class. Thanks.